Okay, guys, so today we're going to be looking at lesson 20 problem set. So you should already have your workbook out and turn to lesson 20. In your zone lesson today, you learned about breaking down division problems to show the area model. And so that's what we're going to work on today with our problem set. Now, I like these problems because, as you know, I like to kind of solve puzzles and brain teasers. And to me, that's kind of what these are. They're like fun little brain teasers that you kind of have to unlock. So let's get started. Number one says Alfonso solved the division problem by drawing an area model. Okay, well, area model we're familiar with. We know that the area model is length times width. Okay, that we've done. We know how to do that. Well, we also know that the inverse operation for multiplication is division. And when we're dividing, we take our quotient and we divide it by our divisor. So in order to use the area model for division, we're just going to be thinking about this differently. We would be thinking that the area divided by either the length or the width, whichever one it is going to give us, again, either the length or the width. So that's how we're going to be processing using the area model for division. You're taking your total or your quotient, you're going to be dividing that by your length, and then that's going to give you your width. Okay, or you're dividing by your width and it's going to give you your length, however you want to look at it. All right, so here's the area model that Alfonso did. It says, look at the area model. What division problem did Alfonso solve? Okay, well, we have his area here of 40 and we have his area of 32. So this is the total area of his entire division equation. Okay, so 40 plus 32, well, I can add that in my head. So I know that that's going to be 72. So 72 would have been his total. And he knew his length was 4, or his width was 4. So 72 divided by 4 would have equaled, well, here is his length, and if I added my length 10 plus 8, because I added my area 40 plus 32 and got 72, so now if I add my length 10 plus 8, then I know that 72 divided by 4 would equal 18. So this was the original division problem that he had to solve, and this would have been his final quotient. Okay, and I know I was saying that the area is the quotient. I apologize for that. The area would be your total, and you're dividing it by your width, and that's going to give you your length, which would be your quotient or your answer. All right, so let's look at B, part B of this problem. It wants us to show a number bond to represent Alfonso's area model. Okay, well, I'm going to start with the total. So I'm going to start with the total and then show how the total is split into two parts. Below the two parts, represent the total length using the distributive property. So I'm going to represent the total length using the distributive property, and then I'm going to solve it. All right, so a couple steps we're going to have to take here. Well, I know what the total was. My total was 72. We just figured that out. So if I take that 72, I'm going to break it into two parts. And remember, when you're doing a number bond, you have your total and then your two parts add together to equal that total. So in my problem, Alfonso used 40 and 32. Now, I'm sure there are other ways that he could have broken 72 apart, but when you look, you want it to be in a way that's going to be easiest for you to multiply and divide. So it's easy to break down 72 into 40 and 32 because you know those are both multiples of 4. So it's going to be easy to figure out what times that 4 would give me 40. Or 40 divided by 4 is going to be easy to solve. And then 32 divided by 4, again, is going to be easy to solve. So the distributive property means that I'm going to take what I have here, 40, and I'm dividing it by 4. And then I'm going to take this part here, 32, and I'm going to divide it by 4. So I'm dividing both parts by 4. That would be the same as if I divided 72 by 4. But once I get these quotients, I'm going to add them together. So 40 divided by 4, I know is 10. 32 divided by 4, I know is 8. And so then 10 plus 8 is going to equal 18. So I know that 72 divided by 4 is going to equal 18. So it's kind of like solving a puzzle. And so, it's kind of, I think they're fun. I like doing problems like this because you really have to think. And like I said, it's like solving a puzzle, and you know how much I love doing that. All right, so let's look at number 2 and let's see what we have here. So we are solving 45 divided by 3, okay? I'm going to pause the video and try and zoom this in a little better so that you can see the problem a little better. All right, I think that's a little bit better. Okay, so we are going to solve 45 divided by 3 using an area model. Then we're going to draw a number bond and use the distributive property to solve for the unknown length. Okay, so I know that I'm going to be using an area model. So I'm going to go ahead and draw my area model here. And my area model is going to show 45 divided by 3. So I know that 3 is going to be my width. And I want to think of what are multiples of 3 that could get me close to 45 that would be easy to divide. Well, the first one that I know that 3 times 10 would be 30. So I'm going to start with 30. So I'm going to make this 30, which I'm going to make that a little bit bigger than the other side because I have 30, and then 30 plus 15 is 45. So I have my area of 30 and 15. So now I just need to think about 3 times what would give me 30, because remember, I'm solving for my unknown length. My unknown length is going to be whatever 30 divided by 3, or 3 times what equals 30. Well, I know that 3 times 10 equals 30, plus 3 will go into 15 5 times. I know that 3 times 5 equals 15. So 45, because 30 plus 15 is 45. 45 divided by 3 must equal 15. All right, let's draw our number bond and see if we're right on this, okay? So here I have 45, and if I want to split that into 2 multiples of 3, that would equal 45. So I know that 3 times 10 is going to give me 30, and I know that 3 times 5 is going to give me 15, and 30 plus 15 is going to equal 45. So now I have to show this using the distributive property to solve for the unknown length, okay? So basically what I'm doing here is I'm saying 30 divided by 3, okay? And I'm going to put that in parentheses because I'm going to solve that problem. And then I'm going to add that to 15 divided by 3. So now I can solve. 30 divided by 3 is going to be 10, plus 15 divided by 3 is going to be 5. So 10 plus 5 is going to equal 15. So that means that 45 divided by 3 equals 15. So I find these fun. I like breaking these apart and breaking it down to the smallest possible unit, I guess, to get my answer. All right, so let's look at number 3 here. Number 3 says that I'm going to solve 64 divided by 4 using an area model. And then I'm going to draw a number bond. Okay, so I'm going to use the area model to solve 64 divided by 4. I'm going to draw a number bond to show how I partition the area. And I'm going to represent the division with a written method. Okay, so here we go. I'm going to make my area model, first of all, to represent 64 divided by 4. So I know that 4 is going to be my width, okay? And I want to think about what is a multiple of 4 that I know that's kind of a big multiple that could get me close to 64. Well, I know I always go to 10s. Y'all know that. So I'm going to shoot for a 10 here. So I know that 4 times 10 would be 40. And 60 minus 40 is going to be 24. So I can pretty much do that in my head. So let's see. 40 divided by 4, that's going to be 10, plus 24 divided by 4, well, that's going to be 6. So that one was kind of easy. So 16 would be my quotient of 64 divided by 4. All right, let's show that with a number bond. So here I have 64, and I'm going to split that up into 40, or decompose it, I guess I should say. 40 and 24, because 40 plus 24 is going to equal 64. And if I divide both of those by 4, I would do the distributive property here. I'd have 40 divided by 4 plus 24 divided by 4. So 40 divided by 4 is 10, plus 24 divided by 4 is 6. So 10 plus 6 would equal 16. Now, this tells me to represent this division with a written method. So I'm going to choose to use an algorithm to do this. So we're going to use 64 and we're going to divide it by 4. Well, I know that 4 can... Hold on, if I'm doing my algorithm, I'm doing daddy, mommy, sister, brother, rover. Can't forget that. All right, so the first thing I'm going to do is I'm going to divide. Well, I have 6 10s, and I'm dividing them by 4 1s, so I know that 4 can go into 6 one time. So now I'm going to multiply. 1 times 4 is 4 10s. It's going to be 40. Oh, looky here. That's what I got right there. So I'm going to subtract. So 6 minus 4 is going to leave me with 2 10s. I'm going to bring down these 4 1s. So now I have 24 1s. And I'm going to have to repeat because 24 is much bigger than 4. Okay, so again, I'm going to now divide 24 by 4, which is the same thing I did up here in this area model. So I'm going to I'm dividing 24 by 4, and I know that that's going to equal 6. So I'm going to multiply 6 times 4, and that's going to give me 24. I'm going to subtract. I have 0 remaining. I have nothing to bring down. I do not have a remainder. So my final quotient is 16. So there was 3 different ways for me to figure out the quotient for the number 64. Kind of cool, huh? All right, so now I want you to try and do number 4 independently, okay? Number 4 says that you're going to solve 92 divided by 4 using an area model. So you're going to use an area model to show 94 divided by 4. You're going to explain using words, pictures, or numbers the connection of the distributive property to the area model. Okay, so you can use words, pictures, or numbers. I personally would probably use numbers to show how the distributive property, if you look right here, as a reminder, we just did the distributive property, and it links directly over to my area model that I did. Okay, so I want you to try this independently. And remember, guys, there are multiple ways that you can break 92 down. You can decompose it into multiple parts. So I want you to try it independently and then come back and see how you did compared to how Miss Havasik does. Okay, guys, so on this one, I actually did it 2 different ways because you may have decomposed 92 differently than I did. So I wanted to show the 2 most common ways. You may have decomposed it differently. As long as, however you decomposed it, you did not end up with a remainder when you were dividing your parts, it's perfectly fine. Okay, so the first way that I chose to do this is I said, okay, I know that 80 can be divided by 4 and 12 can be divided by 4 equally. And I know that 80 plus 12 is 92. So I chose to do it that way. And I said, okay, I know that 4 times 20 equals 80. And 12 divided by 4 is 3. So 20 plus 3 would be 23. So I knew that 92 divided by 4 would equal 23. And here I broke it down into the distributive property. I have 80 divided by 4 is 20. 12 divided by 4 is 3. 20 plus 3 is 23. Over here on this side, I have 40 plus 40 plus 12. So I chose to break 92 down a little bit more than I did in the first problem because I knew 4 times 10 would be 40. And 40 plus 40 would be 80. And 12 more would be 92. So I chose to do this one this way. When I break it down into the distributive property, I have 40 divided by 4 plus 40 divided by 4 plus 12 divided by 4. So I had 10 plus 10 plus 3, and my quotient was 23. So I got the same quotient both ways. All right, last one. I want you to try number 5 independently, and then you can come back and check your answer. But guys, remember, it's up to you to try. Okay, so I hope that you tried this on your own. You may have broken it down differently than I did, and if you did, that's okay. As long as you got the same quotient that I got, then that's okay. I chose to break it down into 60 plus 12 because, again, I always try and go for those tens, so I knew that 6 times 10 would give me 60, and that would leave 12 from 72. So 60 divided by 6 equaled 10. 12 divided by 6 equaled 2. And when I added the two of them together, I got my quotient of 12. Now, this also asked me to solve this using the standard algorithm. So 72 divided by 6, the 6 I could divide my 7 by 6, and that would be 1. And then I multiplied. 1 times 6 was 6. I subtracted. 7 minus 6 was 110. And then I brought down my 2 ones. So I had 12 ones. So 12 divided by 6. And look, that's the same thing we did over here. 12 divided by 6 was 2. So I multiplied. 2 times 6 was 12. I subtracted. I had 0 left. I had nothing left to bring down. I did not have a remainder. So my quotient was 12. So it's just kind of a fun way, guys, to play with the numbers and see how many different ways and strategies you can use to help you to understand long division. All right, I think you're ready for your exit ticket. Go ahead and get it done.